So I've had quite a few requests for some videos for the final exam, and so you asked for it, and here it is. So this is going to be a video just over all of the topics that are going to be on the final exam, and you can see I have all of them laid out here. I'm going to talk through what these topics are, how you should study for them, and specifically which areas you should really be focusing on. And then I'm going to make some subsequent videos where I'm going to talk about the equations for each of these chapters. So if we look all the way back at the beginning, Chapter 1 talked about units and dimensional analysis, and how you can convert between units. Now, I would say that I wouldn't spend a lot of time studying that because it's really, those are topics that we cover throughout, and that you need to know how to do those things in order to be successful in all the other ones. So I wouldn't really spend a lot of time focusing on Chapter 1. For Chapter 2, we talked about one-dimensional motion. So we related the acceleration, the position, and the velocity of a particle to its time, and we had several equations that could describe that. Chapter 3 introduced vectors, because what we wanted to do is we wanted to take those equations for one-dimensional motion and generalize that to two-dimensional motion, and that requires us to introduce vectors. Again, I would say you don't really need to spend a lot of time studying Chapter 3 because those equations come up in other sections, like when we talk about two-dimensional motion and Newton's laws. So getting on to the two-dimensional motion, that was when we talked about projectiles. And so really all we did was we said, okay, well, for one dimension, we had this set of equations. And then we could extend that to two dimensions by saying there's a set of equations for x and a set of equations for y, and then put those together in order to do some calculations. In Chapter 5, we talked about Newton's laws. So we want to know what Newton's three laws are and how to use them. That leads us into Chapter 6. Chapter 6 is really the application of Newton's laws. So those are all the problems where we had a block on an inclined plane. What's going to happen to it? How can we talk about how the normal force on something is related to its force of gravity? Things like that. After our application of Newton's laws, we talked about work and kinetic energy. So if we had some force and it goes some distance, we can say that that product is going to be equal to the change in kinetic energy. That's our work energy theorem. After the work energy theorem, we talked about potential energy and conservation of energy. So we could say if I had a box or a ball and I hold it up in the air, it has more gravitational potential energy than it does down here. And if we can write what the energy is here, we can write the energy here. We can set those equal to each other by using conservation of energy. And there's a lot of interesting things that we can do with that. This is also where our energy bar charts came into play. The next topic that we talked about was linear momentum and collisions. So if you have some mass and it's moving with some velocity, you can calculate what the momentum is. And then we talked about what happened when you had two objects and one of them hits another one, and what types of collisions can you have, and what quantities are conserved or not conserved. After that, we talked about rotational kinematics and energy. So if you watch the videos that I did for the third test, I talked about how you can really relate one-dimensional kinematics for translation to one-dimensional kinematics for rotation. That's this chapter. And then we also talked about the energy for something that's rotating. So we had a kinetic energy for something that's translating. We also had a kinetic energy for something that's rotating. That's all in the videos I made for the third exam. After that, we talked about rotational dynamics and static equilibrium. So we had, again, going back to the videos that I made for the third exam, an analog to Newton's second law. So Newton's second law says that the sum of the forces is equal to the mass times acceleration. You can also say that the sum of the torques on an object is equal to the moment of inertia times its angular acceleration. And so I drew a strong parallel between those two, and then talked about the special case of what happens when the sum of the torques is equal to 0 and the sum of the forces is equal to 0. That's our condition for static equilibrium. After that, we talked about fluids. So when we talked about fluids, we talked about pressure. We talked about Archimedes' principle. So what is the buoyant force on an object? And that was the end of all the material on the third exam. So after that, we also had the continuity equation for fluids and Bernoulli's equation. We haven't tested you guys on those yet. So be sure you study that. And that's it for fluids. So after fluids, we talked about temperature and heat, and specifically, we talked about what happens if I have a bar and it's at a certain temperature and it has a certain length. What's going to happen to it if I increase the temperature? We know that it should expand. After that, we talked about the laws of thermodynamics. So the first law of thermodynamics, how does the internal energy of a system relate to the heat that you add to it, and the work that that system does, as well as what types of processes can we have. We can have an isothermal, an adiabatic, isobaric, and an isochoric, and how can we do calculations with those. So to round everything out and to tell you where I'm going to go with the rest of these, like I said, I wouldn't spend a lot of time on chapter 1 and 2 because these we use those results for everything else, and so if you can use the results, you really know what's in chapter 1 and 3. For the rest of it, I'm not going to make any videos on anything that was on the third exam because I already made those videos. So all of this, with the exception of fluids. Fluids, I didn't talk about the continuity equation and Bernoulli's equation, so I'll include those. So that's going to be it for just setting the stage. Stay tuned. I'm going to have videos for the equations that we're going to have for all of these chapters, with the exception of the rotational kinematics, dynamics, and portions of fluids. Okay? Oh, God. How do I stop?